In this video, we will do problems from exercise 3.6. Question number 4. Show that cos pi by 15, cos 2 pi by 15, cos 3 pi by 15, cos 4 pi by 15, cos 5 pi by 15, cos 6 pi by 15, cos 7 pi by 15 is equal to 1 by 128. Now pi by 15 is 190 divided by 15, which is equal to 12 degrees. Therefore, our LHS becomes cos 12 degrees, cos 24 degrees, cos 36 degrees, cos 48 degrees, cos 60 degrees, cos 72 degrees, cos 84 degrees. Let us consider the expression cos A, cos 60 degrees plus A, cos 60 degrees minus A. Let's bring to our memory some of the formulas. So let's first apply this cos A cos B with A as 60 plus A and B as 60 minus A. And let's replace this expression here. So this will become cos A 1 by 2 cos of A plus B, which is 60 plus A plus 60 minus A. So A and A will get cancelled, so you'll get 2 times 60 degrees. So we can write this as 2 times 60 degrees. Then you have cos A minus B plus cos A minus B. So when you do A minus B, 60 and 60 will disappear. This minus A will become plus A, so it will be 2A. Now, for the first term, cos 260 degrees, let us use this expression here. So, cos A 1 by 2, instead of cos 260 degrees, let A be 60 degrees. So this becomes 2 times cos squared 60 degree minus 1. And for the second expression, cos 2A, let's use this formula here. So the 2A, cos 2A becomes plus 1 minus 2 times sine squared A. 1 and 1 will get disappeared. Then you have 2 as a common term, and you have a 2 here. So these 2 will disappear. So you will be left with cos A cos squared 60 degrees minus sine squared A. Now let's replace sine squared A with 1 minus cos squared A. So this is equal to cos A within bracket cos squared 60 degrees minus 1 minus cos squared A. Okay. So further simplifying, cos 60 is 1 by 2. So cos squared 60 will be 1 by 4. So this is cos A into 1 by 4 minus 1 plus cos squared A. Further, this is equal to 1 by 4 minus 1 will become minus 3 by 4. So this is equal to cos A into cos squared A minus 3 by 4. Further, taking the cos A inside, this becomes cos cube A minus 3 times cos A. Now look at this formula. You will see that this is in the form of, there is a 4 here, sorry. So this is in the form of cos 3A, the numerator. So this is equal to cos 3a divided by 4. Therefore, cos A, cos 60 degrees plus A, cos 60 degrees minus A is equal to cos 3A by 4. Let's mark this as 1. Now from our left hand side, let's take cos 12, cos 48 and cos 72. So cos 12 degrees, cos 72 degrees and cos 48 degrees will be equal to cos 12 degrees into cos 60 plus 12 degrees into cos 60 degrees minus 12 degrees, which is nothing but from 1 we know it's cos 3 times 12 degrees by 4, which is equal to cos 36 degrees by 4. And that's nothing but cos 36 degrees is given by root 5 plus 1. So it's 1 by 4 into root 5 plus 1 divided by 4. So that's equal to 1 by 16 into root 5 plus 1. Similarly, let's take the other 3 expressions, which is cos 24, 36 and 84. So cos 24 degrees, cos 84 degrees and cos 36 degrees. So what we have here is cos 24 degrees into cos 60 degrees plus 24 degrees into cos 60 degrees minus 24 degrees. So that's nothing but cos of 3 times 24 degrees by 4, which is nothing but cos of 72 degrees divided by 4. Now we can rewrite 72 as 90 minus 18. So this becomes cos of 90 degrees minus 18 degrees divided by 4, which is equal to sine 18 degrees by 4, and that's equal to 1 by 4 into root 5 minus 1 divided by 4. That's 1 by 16 into root 5 minus 1. So now our left hand side will become 1 by 16 root 5 plus 1, and cos of 60 degrees is 1 by 2, and the next 3 terms would be 1 by 16 into root 5 minus 1. So that's nothing but 1 by 16 into 16 into 2 into root 5 plus 1 into root 5 minus 1 will be 5 minus 1. So therefore it's 4 divided by 16 times 2. So 4 times 16 times 2 is 128. So that's equal to right hand side. Hence the proof. Question number 5. Show that sine 8x cos x minus sine 6x cos 3x divided by cos 2x cos x minus sine 3x sine 4x is equal to tan 2x. The formulas that we'll be using are these 6 formulas. So let's take each expression from the left hand side. So let's first take sine 8x cos x. So sine 8x cos x. Now let's put this on this formula here, with a being 8x and b being x. So this is equal to half of sine a plus b. A is 8x and b is x. So it is a plus b is 9x plus sine 8x minus x will be 7x. Let's call this as 1. Then sine 6x cos 3x, again using the same formula, this becomes sine 9x, 3x plus 6x is 9x, plus 6x minus 3x will be 3x. So sine 3x. So let's call this expression 2. Then let's take from the denominator cos 2x and cos x. Cos 2x cos x, and let's use this formula here. So this becomes half of cos a plus b. A is 2x, b is x, so it's cos 3x, and plus cos a minus b, which is plus cos x. 2x minus x will be x. So let's call this as 3. Then the last term, which is sine 3x sine 4x, and that's equal to half of, let's use this formula here, cos a minus b, taking our a as 4x and b as 3x, a minus b will be cos x, then minus cos of a plus b, so that will be cos 7x. Let this be 4. Now substituting using 1, 2, 3 and 4, our LHS is equal to, let's substitute the values, half of sine 9x plus sine 7x, which is for sine 8x cos x, which is this term here. So we are putting what we found in the equation 1. Then it's minus, then the second term is half of sine 9x plus sine 3x divided by, whole thing is divided by cos 2xx, which is the expression in 3. This is half of cos 3x plus cos x, then it's minus half of this expression here, this is cos x minus cos 7x. Okay, now half is common for both numerator and denominator in all the expressions, so that will disappear. Then your sine 9x minus sine 9x will disappear. So in the numerator you will be left with sine 7x minus sine 3x divided by, in the denominator your cos x and this cos x will disappear. Cos x minus cos x will be 0. So you'll be left with cos 3x, minus into minus is plus cos 7x. Okay, now let's, for the first expression here, which is the numerator, let's use this formula. So the numerator here will now become 2 times cos of c plus d, or c is 7x, d is 3x, so that is 10x divided by 2 into sine c minus d. So 4 minus 3 will be, 7 minus 3 will be 4. 4x by 2 divided by, and the denominator is cos 3x plus cos 7x. So we can replace, our c and d as 7x and 3x. So this, using this expression, this becomes 2 times cos of 10x by 2 into cos of 4x by 2. So these two 2's will disappear, and these two expressions will are the same, they'll disappear. So you're left with sine 2x divided by cos 2x, which is nothing but tan 2x, which is equal to RHS. Hence the proof of the question. Question number 6. Show that cos theta minus cos 3 theta within brackets times within bracket sine 8 theta plus sine 2 theta divided by within bracket sine 5 theta minus sine theta times within bracket cos 4 theta minus cos 6 theta is equal to 1. The formulas we'll be using are these three. So let's take the first expression here in the numerator, which is cos theta minus cos 3 theta. Now we can use this formula here for this, where C will be equal to theta and D will be equal to 3 theta. So this is equal to 2 times sine of C plus D, which is theta plus 3 theta divided by 2 times sine D minus C, which is 3 theta minus theta divided by 2. This will be equal to 2 times sine 2 theta into sine theta. Next, let's take sine 8 theta plus sine 2 theta, and let's use this formula here. So C is equal to 8 theta and D is equal to 2 theta. So that's equal to 2 times sine 8 theta plus 2 theta divided by 2 into cos 8 theta minus 2 theta divided by 2. So that's equal to 2 times sine 5 theta into cos 6 theta by 2 will be 3 theta. Let's define this as 1 and this as 2. Then let's take the third expression here, which is sine 5 theta minus sine theta. Sine 5 theta minus sine theta is equal to, let's use this expression here. So it's 2 times cos C plus D, so it's 5 theta plus theta divided by 2 into sine C minus D, so 5 theta minus theta divided by 2. So that's equal to 2 times cos 2 theta into sine, this is 3 theta here, 2 theta. Let's call this as expression 3. Then the last one, which is cos 4 theta minus cos 6 theta. And let's use the last formula again. So this is 2 times sine C plus D, so that is 4 theta plus 6 theta divided by 2 into sine D minus C, so 6 theta minus 4 theta divided by 2. So that's equal to 2 times sine 5 theta sine theta. This is 4. So from 1, 2, 3 and 4, our LHS is now equal to 2 sine 2 theta sine theta times 2 times sine 5 theta cos 3 theta divided by 2 times cos 3 theta sine 2 theta times 2 times sine 5 theta sine theta. Now you'll find all common expressions. 2 and 2 get cancelled. Now we have a sine 2 theta here. So sine 2 theta will disappear. Sine theta and sine theta will disappear. Sine 5 theta and sine 5 theta will disappear. Cos 3 theta and cos 3 theta will disappear. So you are left with 1. That's equal to RHS. Hence the proof. Question number 7. prove that sine x plus sine 2x plus sine 3x is equal to sine 2x times 1 plus 2 cos x. Okay, so here we'll be using the formula sine c plus sine d. Alright, so now let's consider the left hand side. So left hand side is equal to sine x plus sine 2x plus sine 3x. Now let's rearrange this as sine 2x plus sine 3x plus sine x. Now let's take the last two expressions here and use the formula where our c will be 3x and our d would be x. So this becomes sine 2x plus 2 times sine 3x plus x divided by 2 cos 3x minus x divided by 2. So this becomes sine 2x plus 2 times sine 4x by 2 will be 2x into cos, again this is 2x by 2 will be cos x. Now we have cos 2 sine 2x as common, so let's take that out. So this is sine 2x into 1 plus 2 times cos x. That's equal to our right hand side, hence the proof.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.